Okay, diba? So now we draw the overhead, okay, product. And now we have here, as I'll show you, the vapor will go up. Okay, this is letter V. And then the liquid will go down. This is L. Okay? The liquid will go down, the vapor will go up. And then this vapor, we need to condense this in a condenser. Okay, like this up. This is condenser. Letter C. I'll just put letter C because we need this. This is a condenser above in the overhead portion of the distillation column. Okay, and now it has a reflux drum somewhere here. So I'll just put RD. Okay, after the reflux drum, we have a pump, a motor pump. Okay, we're not concerned for the horsepower for this motor as long as this motor will work properly to deliver the distillates outside and to deliver the reflux in going back to the distillation unit. Okay, this motor pump. Okay, so I will show you that the liquid will go back to the distillation unit, and some or more of the liquid will rather, it will become an overhead product. Okay? So guys, it's very clear that a portion only of the overhead product, which is the distillate, will go back to your distillation column that is called reflux. So that is L over V. Okay? The liquid will go down and then over the V, the condensate. So, meaning distillate over the condensate. So this is the portion where proves that there's no heat loss or there's no heat of mixing somewhere along the way in the equilibrium stage of this vapor and liquid. That's why you observe the values of the heat of vaporization and the heat of condensation are not used in the equations because according to the McCabe-Thiele method, there's no heat of mixing, and at the same time, the latent heat of vaporization is negligible, and the equimolar flow is constant also somewhere along the way. Okay, so these three requirements must be fully satisfied before we will use the McCabe-Thiele method in computing the y-intercept, the slope, the feed, what's come in, what's come out, like this, blah, 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 blah. So, or else we'll never use the distillation in this manner if that will not be satisfied. You get the point? Muna siya ang theory sa distillation. Okay. Now, so we have now the graph here. So let's try to solve first directly the letter A. So, kaya direct na ka siya linear equation. Later na ang finding the number of stages, trays, and number of plates. Usually in an industry, guys, the one I put horizontal lines are called sheave trays. S-I-E-V-E. Trays. T-R-A-Y-S, or a plate. Metallic trays or metallic plates, specifically sheave trays or sheave metallic plates. Okay, that's what we're trying to compute or determine by having this kind of problem solving. But of course, the actual number of plates are discovered already in the actual scenario in a plant or a factory. We're just trying to, to predict what are the number of theoretical plates needed. Okay? Right? And the actual already have. Okay? There's no need to compute, but there's only for, further understanding if you will work in the real world of factories and plants that have so many distillation columns and distillation units. So we can understand also what's going on. Okay? It actually already have there. When they buy the distillation units, already have the plates inside. Okay? Something like that. Okay? All we have to do is to buy only na lang siya. We don't fabricate. And then, i-compute na to ang number trays. We don't do like that. The employer will just buy that unit. Okay? Having the correct technical specifications submitted by the engineers. Okay? The technical engineers or the process engineers will do that usually. Okay, and after complying with those specific requirements, the specifications, as per the basis of the operating parameters, then bingo, they can buy and purchase the units. Okay, it's gonna be like that always. Okay, we don't need to create and fabricate and to have our own engineering design. Okay, it's already there in the market globally, and you have to buy only. Okay, in most cases, okay, unless we are producing distillation units as our product, we need to design that because that's our product, but it's not the story like that. We need that to produce the products. Okay, we need that distillation units to produce the products. We are not trying to make or fabricate that distillation units, or else it will add costs to our company. Okay, for the engineering design stage for that particular distillation unit, so you add problems in your industries. Okay, as long as we have the capital investment, then we have to buy those equipment and units for the particular purpose, something like that. And the engineers are very clever to that. Okay, because we know the parameters, operating conditions, something like that. I discussed it already, right? The different operating parameters and operating conditions in a physical and chemical separation processes. Okay, if you don't know that one, mga mutigid na. Okay, so we should understand those operating parameters and specifications, something like that. So engineers knows that. Okay, okay. Going back to this. Oh my gosh. Okay, now how much feed to be introduced? Oh my gosh, very difficult. Right, in the actual scenario, the feed already know. We know already the feed. How much we going to introduce in the feed, right? Our raw materials. But here, the problem tells us how much feed to be introduced. Imagine. So this is gonna be unrealistic, right? In the real world. Get the point? Because we ask how much feed you introduce, what's the amount. But if that is the case, we cannot produce the desired product we want if we don't know the amount of the feed or the raw materials we introduced there, the inlet. Okay, you get the point? So this is only for learning purposes, this problem solving. Okay, it's gonna be like that. Okay, so overall material balance. Okay, let's put D in the overhead product distillate, something like that. Okay, so this is the bottom product. Okay, I have to put specifically the another terms so that we will never be confused. Okay, bottom product. Okay, condensate, overhead product, distillates, something like that. Okay, the distillate will be letter D, right? And then W is the bottom product. Now you are questioning, Mr. Sotero, ang layo ng W sa bottom product. I don't know. Question the books. Okay, because the books are representing a letter that is very far from the first letter of the term they are referring to. If I am just only a scientist in that particular time, I will recommend to this Newton, Anton Lavoisier, Michael Faraday, like that, John Clerk Maxwell, Heinrich Fritz sa Hertz, okay? Discover siya sa katungkuan, di ba? Photoelectric effect. Ako siya nang nun, yung paggamit ng mga kuan, mga letter nga, layo ka sa terminology, kaya maglibog ba yung mga estudyante, but nobody pushed them to do that. Okay? As reflected in the book, W means bottom product. W means the condensate. And it's very far also to the condensate. Dapat sana C. Right? Because condensate is the first letter is letter C. Capital C. But why W talaga? Okay, nakakaloka. W stands for water. Okay? If you can remember the triangle in the NFPA, in OSH, National Protection, okay, Agency, katong kuan, NFPA 704 standard in environmental health and safety, that could stand for water, okay, and then water, and then this underline in the center, meaning to say you will never introduce the product or chemical products to water because it will explode, something like that. The W there is water, the capital W in the triangle. Okay, in different tanks. Cylinder, water tanker, fuel tanker for the transportation of the chemicals, something like that. The standard is there, NFPA 704. There's a color chuba chuchu. Red, flammability. Okay. Yellow, reactivity. Blue, toxicity. And white is the specific hazards according to corrosivity. You know, corrosion, how corrosive is the chemicals really are. Something like how it is being oxidized if we add water or if we remove water. And then W also is there in the white color, because that means you will never introduce that with water because it will explode when you contact that to water. If you see a capital W na ay horizontal line sa tunga, that means you will never expose that chemicals to water because it will react to water and will react violently and cause explosion. Okay, so that's gonna be the information about the diamond in the tank. Yellow, red, white, and blue. And these are what we know as hazards identification, classification of the different substances, and that's under occupational safety and health related to chemicals. Now, if you are chemical engineers, you can easily understand what's all about that, especially BS chemistry graduates also, okay, because it deals with the chemicals and various substances. You're not limited only to liquids and gases. Okay, going back. Now we go to the overall material balance for this, and it's very clear, right? Okay? Phi, capital F, is equal to capital D plus capital W, because the D and W will go out from the distillation unit, something like that. And what comes in is the capital F. So F is equal to T plus W. Okay, this is equation 1. I'm talking very fast, okay, to save time. So F, oh my gosh, the token is almost finished. Sorry guys. Kaloka. Maginit kami ang kinabuhi sa unit operations. I will tell you frankly. Overall material balance and energy balance. And the rest will be chuva chuchu. What do you mean by chuva chuchu? Kuan ko siya. Basta, tanan na siya yung combine ng mga theories, topics, principles, concepts, basic foundation designs. It will be combined and will be used there in higher subjects for chemical engineering and for BS chemistry. Kaya related ba dyan ang BS chemistry o ang chemical engineering? Okay, related courses. Okay, but they are more on the principles, but we are on the application. That's the only difference. Application. Okay, by having the technology, the mathematics, and the science, because usually engineers will design. Okay, will design a chemical reactor, nuclear reactor, something like that. But the chemists cannot design. They are focused inside the laboratory. Okay, but chemical engineers can go outside in the laboratory. They can still also work in the laboratory, but at the same time, they can go out in the laboratory to act as a process engineer, and then they will also try to be more versatile. Okay, like that. They can do in another way around, and they can sign also documents, especially in the Philippines. Registered chemical engineers can sign the documents. Okay, so the chemists have limited responsibility. They cannot sign documents related to chemicals. Okay, for example, if your products will be released to the market in international level, the chemical engineer will sign, not the chemist. But the chemists can sign in their laboratory testing, the results during their testing, but that's there only. What I mean, if they try to release that in the global market, the licensed registered chemical engineer will really sign the products, especially if it is a hazardous products. You get a point? Hazardous materials products, really. It is very dangerous to the environment and to the humanity. So it really needs a declaration of signatories, something like that. Together with other engineers also. It could be the mechanical engineers, electrical engineers, the architects, or civil engineers. So those professions can sign a document legally. Okay, if registered. Okay, now OMB. Okay, OMB. So here, that capital F, D plus W. Saan ba kayo gan? Guys, murag elementary level, magiging siya. Wow. Sorry for that term. Okay? Plus na ba yan siya? F is equals to D plus W. Don't tell me a grade 1 student cannot do this. Giadra ko lang ang W. Imagine. Okay? The analysis, what makes the problem solving difficult. But the basic formulas and equations, anybody can do that. But on how to solve what is being desired or being asked in the problem is the most difficult part because it involves analysis. Okay? Every individual don't have the same analysis. That's why it matters there. Okay? Not on the formulas and equations. Okay? You get the point? No. Now, energy balance. Okay. Energy balance. Oh my gosh, my temperature are almost consumed. Why not this? Oh my gosh. Tabian kaayo. Wow. Maujig mo. Okay. F. Di ba ningon ko ganila nga, mole fraction is nawala na ang percent, kay gikan na siya sa mole percent is equals to mole of solute over the mole of solution times 100. Okay? Other problems will just specify mole percent of benzene, yung ganun siya. But other problems also go directly to the mole fraction. You will just put X, C6, X6, means mole fraction of benzene. But it's not the same story all the time. That's why you need to think, okay? Because not the same all the time. Sometimes we'll put mole fraction, sometimes mole percent, and in fact, sometimes you will put volume fraction. Okay? But you do it in a mole fraction. How can we do that? Again, by basic in chemistry, molar volume. Again, magbalik-balik na puntaan eh. Molar volume, okay? So, the specific volume amount given in the problem over the number of moles. So, naman tayo, gipangutan naman tayo mga volume, then imong kuha ang number of moles. Kaya given sa problem, volume and fraction naman siya. Okay, nga na ba? Okay, and then sometimes mass po na siya. Here. And then you will use the molecular weight. Remember that one? Okay, molar mass, nandun na siya, chuba-chuchu. Okay, get the point? Molar volume is equal to the volume, specific volume amount given in the problem over the number of moles. Okay, mass fraction is equal to mass of solute over the mass of the solution. And sometimes a molar mass is equal to the mass given in the problem over the number of moles. Imojukti man ang guys, ang number of moles, pero hindi na siya to the denominator. Okay, kaya times niya sa moles, sa equation, sa chemical equation, makancel man ang moles na yun. Wala nilabad sa ulo. Mauna ang hinungdan na ang number of moles na ginagawa sa denominator, ha? You got that point? Unless you'll be using the conversion factor in your equation in your formula. It will magtutuwad na siya pwedeng numerator, pwedeng na denominator, as long as it will cancels out. But if we refer to the original formula, the number of moles will be in the denominator. Get the point? Always. Forever. Okay. That's straightforward. Okay? Like that. So, OMB. So, F times XF, the mole fraction. So, ibig sabihin nila ako guys na 0.6, kinamatay 60 mole percent. Madugay mo ko kung kuanan pa na ko 100. 60 divided 100, so more gapon siya. So, that is XF is equals to 0.6. Okay? Ay, naku. Maloka. Okay? Napuang. Okay? Guys! Are you still there? Okay. So, XF is equals to 0.6 na good siya. Okay? Guys, you have to remember that feed always have a bigger amount because it's still a feed going there in the distillation column. Sometimes you have to think, okay? Baka mag-rumble-rumble siya, then okay? It's gonna be FXF is equals to DXD plus WXW. This is energy balance equation. Equation number 2. Okay? So I have to put equation 1, equation 2. Now, you visualize what other mole fractions given here. So here, okay, a given product of 95% mole of the CH6 and bottom product containing 10 mole percent of benzene. See? So, bottom product containing 10% mole of benzene and 95% mole of benzene. So here, tataw o klaro kaayo na ang distillate dako siya value. So our XD here of the distillate is the 95% mole percent. Again, 95 moles divided by 100 moles, our basis of calculation, times 100. It will become X of the distillate or mole fraction of the distillate of this benzene particularly is equal to 0.95 of our XD. Wala na siya ang our XD. 0.95, dako man siya. Ibuan naman yun mo. Okay? So, Ang habilin guys, ang bottom na siya, mole fraction siya, bottom, which is the condensate. Ano siya ang gamay? Ang bottom product containing 10 mole % of benzene. Okay? We should know this because it will matter in our McCabe field method application during the graphical representation. Okay? Something like that. So our XW is equal to 0.10. Ganon. O diba? Okay. So, observe this. Nakaluka, diba? Observe this. All mole fractions are given, but the amounts are not given in the feed and distillate and the comes. How can we do this? Okay, just leave this as is muna, ha? Let's do the McCabe field method na. Okay, but we need to solve first the equation based on this. Okay, how much feed? So this is equation 1, feed. We will use this later on. And then number 2, how much distillate? So distillate will be equal to feed minus the bottom product. Okay, muna siya ang distillate. Okay, distillate. Mag-algebra ka, linear equation. So, F is equals to, okay, feed minus the bottom product. Okay, feed minus the bottom product, which is W. Okay, like this. So, muna yung D. Now, how much bottom product produced? Bottom product is W na po siya. So, equals to feed minus distillate po siya. W is equals to feed minus distillate. So, muna yung mga equation yung tukion. Okay? Because the problem asked for this. Okay? W is equals to F minus D. F is equals to D plus W. And D is equals to F minus W. These are all equations obtained from equation 1. In algebra, you need to transpose what you are asking for. Okay? You need to teach because it's very basic, right? Okay, now you don't have values at all, the 3. So make use of the mole fractions here in equation number 2. Okay, since we have 3 unknowns, we have also 3 equations and formulas to be used based on algebra. It's gonna be like that, taking into account how many are being asked, and that's also the total number of equations that we need in our solution, in our problem solving. Unless there are constants to be utilized in the tables or in the graphs somewhere along the way, in the handbook, in the chemistry book, in the physics book. But in this case, we don't use constants here because negligible ang mga heat vaporization at heat condensation. Okay? So it's gonna be like that. Okay, now let's go to the McCabe field method by using this graph. Okay, we have now the XD, which is equal to, we have here, right? 0.95, so i-graphing mo ang 0.95. Here, andyan na naman tayo. So, 0.8. Atong i-divide test, kaya wala man din siya ma-accurate. So, 0.8 plus 1. Di ko makita, no? O, ganun. O, diba? 0.8 is equals to ganun. Divided by 2 is equals to 0.9. Oh, gosh. 0.9 here, but we need 0.95 in the X distillate man siya. So 0.9, oh my gosh, 1 is equals to divided by 2. So we have perfect! The 0.95 is here, in the center, between 9 and 1. Wow, bongga. Okay, here. Okay. Kung ang titaan guys ha, pag may tiyaga, may nilaga. Parang ganun. Because it's very difficult to do this without patience, okay? Like this. My gosh, in fairness. Ganon. So, ato na siya i-connect. Nakakaloka. Okay. Muna niya itong XD, which is equals to 0.95. Okay, ako nag-microphone. Okay, the XD is 0.95. Guys, it's here. XD. First is to make an upper operating line or rectifying line. Muna itong gibuhat karon. So we need to intersect the distillate mole fraction and the y-intercept. So what is the formula of y-intercept? And now we will compute for the slope equation for the rectifying line. Okay. You should memorize this. 1, 2, 3, 4. 4 equations only in distillation. Okay, the rest will be history because I try to rumble like this. Okay, tutuwaran na yun. Ay, naku. Okay. So, slope is equals to R plus R1 times the value of X generally. This is small fraction generally, ha? So usually this is a rectifying line, so this is understood to be the feet. Of course, right? Yes, okay. Plus, it's gonna be the XD. Okay, XD over R plus 1. It doesn't make sense, guys, right? Okay, let's, on the spot, let's analyze. If we have the XD over R plus 1, then therefore, this X beside the slope is also XD to make sense, right? Oh my gosh, but the books and, you know, on the online web page that I researched, there's no such declaration that this X here beside the slope R over R plus 1 is the distillate. See, you have to make your own, you know, analysis also. This is parallel, right? Because it's being added. The slope and the y-intercept or the b. So this is expected to be as xd also. Got the point? So that it will not be rambled. Because this y here is solving for the rectifying line. Or rectification or upper operating line. And the upper operating line will be more on the distillate by Yagid Shah. Okay, so this is xd also, right? So, correct me if I'm wrong, because the books I encounter never says that this is the mole fraction of the distillates. If you multiply that in the slope, it's just merely an x. Okay, so things like that, okay, we need to dig it out. Atong tukion. But never mind, this is not our concern really to declare that as an xd or not, as long as we have the slope, right? Why make problem in our head? In fact, we will never solve this x. Okay, but what I understand, this is x, the mole fraction of the distillate also, parallel to the mole fraction of the b, or y-intercept. Okay. Sotero, why b? In algebra lagi, nalagay tayo equation sa slope na y is equals to mx plus b. Dito ni siya gi-pattern. Tanan, no? Bitong gini mo patikon of unit operations or physical chemical principles sa inyong chemical engineering subject kung di mo makapasar sa algebra. Because algebra is very useful. Prerequisite subjects to higher subjects. Okay? Like that. So this is from y is equals to mx plus b. So it's gonna be, mao siguro walang na siya xd po because our algebra is only x ang sa gihapon. General siya form mo siguro. Right? Okay. So ganun na siya. Hayaan mo na siya. Masama na siya ang principle. Okay? But me, I should be particular. Okay? Specifically. So that the students will not be confused. Okay, but anyhow, okay, this is for UOL. And then for the, you know, for the Y, for the BOL, for the FOL. No, UOL and FL only. Okay, we have UOL, BL, and BOL. What is UOL, Sir Sotero? Upper operating line or the rectifying line. What is BL, Sir Sotero? Okay, this is BL. No, it's not BL, it's FL. Feed line. Okay, sorry. Feed line. And we have also the BOL, bottom operating line. This is now your stripping section. Stripping, S-T-R-I-P-P-I-N-G. Meaning the vapor starts to vaporize at this section. Okay, kaya vapor, it will goes up. Okay, something like that. You get the point? And then so there are three sections pala siya. So the rectifying section, the stripping section, and the feed section, which is what we call as the flashing zone section. Okay, so for example, in the examination in the near future, we'll say, what section refers to the feed section? A, upper operating line. B, bottom operating line. C, equilibrium line. D, tangent line. D, none of the above. Okay, the question goes like that. So that will be your flashing zone section. Your feed line or the Q is just changing term. Okay, so that the students will think quickly, what is another term for this? Okay, it needs you to think, oh, there's another term for this. I must know. None. Okay, so y is equals to Okay, Q minus Q1 because it's feed line. Q is represented as small letter Q. Okay, not the heat ha. Q is the feed here in distillation special. So Q over Q minus 1. Again times X. So we need to say pala guys, this X beside the slopes are general. Okay, not particular or not specific. Never mind. Okay, as long as the B-intercept, the Y-intercept are specific. Okay, plus negative XF na siya. Because feed line man ang Q. So negative XF over Q minus 1 na siya ang intercept niya. Okay, this is the feed line, FL. Okay. So ang gamit pala sa bottom operating line, the usage or the application of the bottom operating line has no slope equation. It's only to intersect this UOL or rectifying line and the feed line, the 3 points, so that we can draw the number of stages. That's the purpose only for the BOL. So let's remember, BOL has no equation. Only the feed line and the rectifying line or upper operating line. So that we can very easy for us to think. Okay? So baka maglibog mo, mag-watch yung equation sa kuan. Okay? BOL na, wala ba na siya. Okay? So that we can understand. Ang purpose lang din sa bottom operating line is to intercept this UOL and FL. Okay, so that we can have the number of trays as we connect that horizontally and vertically, we can have the number of trays and stages out of that. Okay, something like that. Okay. Now, so, naman na siya, no? So, mag-create na XD. So, in order to connect this in our feed line, we need to know the Y-intercept here. XD over S plus 1, this is our Y-intercept or the B in algebra. Small letter b is just equal to Y-intercept in the general form of slope in algebra. Okay, y is equal to mx plus b. During the derivation of equations in chemical engineering science, it always used because we will create a right triangle somewhere along in the graph. We use again the Pythagoras theorem several times. Okay, something like that. Or not only in the physical chemistry, but also in the quantum mechanics. Okay, the scattering of light and photons. Okay, something like that. So, we connect na. Okay, there's our XD or put the circle, chuba, chu. So, how can I do this? Okay, I make this big. Okay, this is the point now. Meaning, this is the X distillate ha, ang point 95 akong gitugkad diri ari. Okay, now, atong i-connect ang Y-intercept. So, XD, okay, Y-intercept. This Y-intercept, guys, is letter B. This Y only is the equation of the slope of the rectifying. Don't be confused. The Y-intercept and the Y only. Okay, it's not the same. So Y-intercept is equals to XD, naman tayo XD na 0.95. Substitute value. Okay, naman tayo 0.95. May pasok din dali. Okay, so 0.95 ay dugaya. Okay? Okay, maabtan tag siyang-siyang na mga sir. Okay? Like that. So, 0.25. And then, Q. Not Q. Yes, Q. We don't have Q here or not have or no. So, let's go back to the sentence. The bottom product containing 10 more % of benzene, the feed enters a column into a bubble point. It is the proposed to operate the column with a flux ratio of 2.5. Okay, we don't have. The Q is not given here. Okay, so we'll just do this Q minus 1. Okay, there's no saturated liquid and there's no saturated vapor. Guys, sorry, na-spot na ni siya good. Okay, never prepare this. Okay, sorry talaga. Okay, so Q minus 1. Or else I can have the Q already. I should not think already. I can put directly, right? I did not prepare this, okay? So Y-intercept is equal to 0.95 over Q minus 1. So wala pa man tayo Q minus 1. Wala pa man tayo Q. Ako sa isang equation 1. Equation 4 na. Kina naman tayo equation 3 na wala ma-solve. Wow. So equation 4. So again, let's read the problem. Maybe there's unsaturated liquid here. A mixture of benzene and toluene containing 60 mol% of benzene is to be separated to a given product 90 mol% of benzene and bottom product containing 10 mol% of benzene. The feed enters a column as bubble point. I think there's a role for this bubble point. And then basing on the definition, we've learned that a bubble point is really the temperature at a given pressure in which the air must be cooled to produce the form, water vapor in its form. To produce a water vapor out of it, something like that. So the product will be vapor, water vapor. So gas. Right? This is what we mean by bubble point by technical definition. So we understand now. So it will form a vapor gas, so it's not saturated pa. Okay. Never mind. So it is proposed to operate the column with reflux ratio. Ano tayo reflux ratio? Okay? Reflux ratio. Oh, ano meron? Reflux ratio. So ganito, L over V. So it's gonna be, oh my gosh, liquid over the vapor. Okay? So L over V lang siya. Actually, kung yung guys ha, ang mubalik ang liquid yun ha. Ano mubalik pa ng vapor nga, gaan ba yan siya? Okay, let's analyze also. The vapor will not go back to the distillation column because vapor is so very light and there's no way to go down. Right? So, by common sense, it's always the liquid will go down because it has a high molecular weight, high density, high boiling point. The point, so the direction of the movement is downward because that is a vertical column. Common sense. Okay? Like that. So, before also, ma-confused pa ko when I was in college, but now I really dig it up. Okay? Supposedly it should be, developed with high theoretical, knowledge. But it's okay. It's done already. Okay? Like that. Okay, so going back. So our y-intercept for feed line is 0.25 over Q minus 1. Naman tayo Q, guys. Now, ato i-compute, let's compute the y-intercept over UOL. So UOL, wala ko, nabuang ko. Buhat ko talaga akong interface ko eh. Kaloka? Guys, so UOL, so di mo na kita nini that XD over R plus 1, y-intercept sa, sa preparating line. So, ganun. Okay, y-intercept, or let's go letter D, no problem, is equals to XD. O, naman tayo XD, which is 0.25 here. Okay, pasok. So, 0.95, charot. Okay, R plus 1, 0.95. And then over R plus 1. Do we have reflux given in the problem? Oh, there is a reflux ratio of 2.5. So 2.5 plus 1, then bingo, we can solve for the y-intercept. This y-intercept, guys, will be used to connect to the XD. And this y-intercept in the BOL are used also to intersect the three sections, in which we don't know. Okay? We will go to the aspect that we know. So it's easy for us to simplify things. Okay? Something like that. So 2.5. Okay, 2.5 plus 1. Okay, 0.99. 95, no? Okay, 95 siya, guys. Okay, so 0.95 divided by 3. Okay, 3.5 is equals to. We have 0.27 y-intercept. Now, plot this in your graph here. 0.27 in the y-axis. Okay? Like that. Okay, ato na siya i-plot ng 0.27. So, ruler. Where's the ruler? Uy, in fairness. Ano ka? Ruler. Where's the ruler? Okay, it's here. So, it's 0.27, right? Okay, now, so, it's between 0.325 and 0.1625, right? Divided by 2. So 0.325 plus 0.1625 is also divided by 2. So this is 0.24375. But this is, okay, never mind pa. Ito yung isang i-compute. So 0.244 lang siya. Round off. And then we have this, okay, divided by 3.5. So we have this 0.27. So, labaw siya gamay, pero naman tayo 0.24 sa tunga here. So, we need to project a little bit higher this 0.24 to somewhere along, okay, to make it sure, let's use calculator again. Okay, so that we will be more accurate. Okay, plus 0.325 is also divided by 2. Oh my gosh, 0.28, so a little bit higher, a little lower, here. And then this plot here, sir, I put 0.27. Let's connect that to the XD. Oh, ganon, ganun to siya. Moment siya, no? Okay, connect. And let's make this a broken line, ha? Okay, broken line. So that it's easy for us to detect. What's this? O, ganun siya. O, nagkamipin mo siya, ari. Okay. Ganon. Uy, green. Oh, no. Masyado nang i-connect. So the green line, guys, the green line above the red diagonal line is what we know as the upper operating line or the rectifying line above the distillation column or upper portion of the distillation column. So we need to label this as UOL. Ganon. We have now got the feed line, the UOL. Now, let's plot also the feed, the XF. So what's our feed? By the way, you should plot all these three mole fractions, not only 2 or 1. So the feed is 0.6, so somewhere along here. So 0.6, ganon chuba chuchu, okay, 0.6. F is feed line, okay, you got a point, okay, like this. What's our equation? Okay, because we're not given a saturated liquid and saturated vapor, it's very easy to detect the Q, okay, but it's nothing. How can we do this? Okay, but it's okay, you need to analyze back, okay. So 0.65 plus 0.8 divided by 2, 0.725, right? 0.725 divided by 2 is equals to 0.6875 here, 0.6875 here. So before that, okay, so 0.65 plus 0.325 divided by 2, this is going to be 0.4875 plus 0.65, okay, ganon. So like that. So 0.65 plus 0.4875 divided by 2. So this is 0.56875, right? Okay, but this is 0.6. So it's gonna be, round off na to or delete? Ay lang. We should not round off because maybe problem. Okay? So 0.4875 here, somewhere here. 0.84875 and then plus 0.65 divided by 2, so 0.56875 somewhere along here. 0.56875 plus 0.65 divided by 2. So it's 0.60 somewhere along here. So this one. So this is our XF, which is equal to 0.6 here. Marked with green, touching the red diagonal line. This is our XF. Okay, actually, it's in here that we can create our Q, right? But we don't know our Q. Okay, where's our equation for the Q? Y-intercept is also 0.25 over Q. So we don't have the Q, right? So we should not use that one. You get the point? So like that. So that's gonna be the situation. Okay? So we go now to the XW na for the bottom. So 0.10, oh bingo, where's the 0.10? Oh, it's somewhere along the way, it's here, 0.10. It's good guys because the values of the Y and X is also in the XWXD. No need to plot again, really, okay, so it's here, 0.1. Okay, it's here, okay, 0.176 divided by 2. So I just prove it now. Divided by 2 is equals to like this. So 0.176. Ang atong XW is 0.10 na siya. Okay? 0.176 divided by 2 is equals to 0.88. So 0.176 plus 0.325 is equals to divided by 2. So 0.2505 on center. And then since this is 0.10, so plus 0.176 equals to divided by 2 is equals to 0.213 and divided by siya. So plus 0.176 divided by 2. So somewhere along here, 0.19 pa dyan siya. So here, so before, so 0.176. Okay. So katunga sa 0.176 guys. divided by 2. So 0.788 plus 0.176 equals to divided by 2. So 0.13 ang katunga niya ani. Okay, so 0.13, 0.13. So somewhere along here, this one is our point 10 here. Okay, this is our point 10. This is our XF is equals to 0.10. This one, XF and XD, and labels my XD, so 0.25. So we have our XF here. Guys, an XF, dili mo ma-connect. We cannot connect XF because we don't know yet the Q. Okay, so what we will do now is to get the slope. Okay, slope is equals to R over R plus 1 na mao ang atong upper operating line. Kaya ganun grade, upper operating line man siya. Okay, so we will use the slope for that, in which the formula is R, right? Because we have no other choice. Okay, the slope of the feed is, we don't have Q. So the other choice left is the slope in the upper operating line. In a way, we can put a dot there and connect the other chupa-chuchu. Okay, something like that. Okay, so slope is equals to pila man itong reflex. It's mentioned in the problem. Do you know how to memorize it? Okay, 2.5. Okay, over 2.5 plus 1. This 2.5 over 2 plus 2.5 plus 1. This is coming from R over R plus 1. Okay, so now our slope will be, okay, 2.5 divided by 3. Okay, 3.5 is equals to 0.71 ang slope. Now, you have the slope, guys. Okay, you have the slope. And this, you know this one, the XF? Take note the XF. The XF, guys, will intersect the upper operating line. So put a dot there because it will intersect man siya. So put a dot there, like this, a dot, something like that. Okay? Okay, ganon. A dot there. So this is for the upper operating line. Okay? Now, by algebra gamit kayo. By algebra, you put horizontal imaginary line. Okay, let's put that straight here. Because guys, our Q is not given in the problem, which is the saturated distillate. It's not mentioned. Usually it will be mentioned, it will produce saturated liquid, blah, 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 so and so. But it's not mentioned here. The saturated vapor, saturated liquid is not mentioned, which is our Q. Okay, so we forced to do this. Okay? So, imaginary horizontal. So this is now our x-axis for this intersection here. Okay, now we have a slope, guys. 0.71. In algebra, kung saan to? Okay, ang slope, definition of the slope is equals to tangent theta is equals to the opposite side over the base. Why? Because if we try to create a horizontal line, this one can develop a triangle. You got the point? By Pythagoras theory. Okay, so we can develop a triangle here. Right triangle, see? Look up. Okay, if you project the hypotenuse, we can create a right triangle. So Pythagoras theorem will be used here. It's no longer the unit operation, but it's algebra. Okay, this is analysis. Okay, something like that. So we need to get the angle of inclination from the horizontal line for the intersection of the upper operating line so that we can connect that to the XW. Okay? Something like that. The moment rule, the XW rule is to connect to the upper operating line. Okay? In the Q. So after getting the angle of inclination, we have the Q naman talaga siya. Okay. Now, so tangent theta, tangent theta is equals to the height over the base. Now guys, you don't have to use the height and the base. Kaya naman tayo value yung 0.71 na slope. Okay? So it will be just equal to theta arc tangent of 0.71. Okay? Like this. Kaya naman tayo value sa puno, magbubuhat pa man ka. Okay? Like this. Kaya ang slope equal man sa tangent theta. Okay, so if we need to say, if you have the 0.71, it is the value when you divide the height and the base. Okay, like that. Okay, so 0.71 arc tangent theta is equals to, okay, so arc tangent 0.71. So we have now 35.38. This is our angle of inclination. Okay, 35.38 degree. Okay. Now project that there in the UOL. So you measure from the horizontal line and just estimate the 35.38 because there's no perfection. Okay, just consider the 90 degrees. And then this is the time you remember the analytic geometry. Okay, 0, 90 degrees, 180 degrees, 270 degrees, 360 degrees. Now we have also the pi over 4, 45 degrees, pi over 2, 90 degrees, 2 pi is 360, correct? And the half will be the pi for 180 degrees. So you should also remember that theory so that you can apply that here also if it is necessary to do so. Okay? But in here muna, concentrate tayo sa angle of inclination. So we need to project 35.38, then we will estimate. Okay? Here, this already the 90 degrees, right? So mag-project 35.38. Okay, here. So approximation na siya. So if you have the 45 degrees here, nakakaloka. Okay? I'll put the blue. Okay? Something like that. Para accurate din siya ba? Natin 45 degrees. Ako gilado na blue. Okay, this one, 45 degrees. Okay, so 45 degrees, i-divide mo 2, kung say value, 45 divided by 2. So that is 22.5. So mag-create na sa kagkatunga sa 22.5. Okay, so 22.5 siya, hindi siya, no? Ang total na makuha mo ang 35.38. So this is, imo siyang approximation only ha, because this is not perfect, this is not graphing paper, as I told you. Okay, like this. So this is 22.5 also. Okay guys, the half of 45 degrees is 22.5. Now the half quadrant of 22.5 sa 45 degrees, ilan siya? 22.5 plus 45 degrees. So it's gonna be, divided by 2. This is 33.75. Close na ba siya sa among 35? Dili pa siya. Our theta is 35.38 and the center between the 45 degrees and the 32.5 is 33.76. So palagwa ni mo gamay, 0.2 para mo 35 din siya sa imong angle theta. It's gonna be here. Okay? Ganon siya. Okay? Palagwa ni mo gamay, ano na siya imong kuan. Angle 35. Ano na siya? 38 degrees. Ako nang i-show ha, ang 35.38 degrees sa, sa operating line. Now guys, this will be your Q. So, i-connect na rin yung XW, nakatang 0.10. Okay, so Q na rin siya. Okay, feed line. So, pila man itong atong XW, i-connect na natin siya sa duha, kaya intersect naman siya. Okay, so connect. So, kini siyang topic. This is all about intersection, connection, tube. Okay, like this. So you need to connect this one here. Kaloka. Okay. Wow. So na-connect na nato ang XW to the upper vertical na gimark na ko blue. Okay. So this is gonna be our intersection among the three. The feed line, the UOL, and the BOL. Bottom operating line. So we have now. Okay, now this is the time, guys, that we need to compute or to calculate the number of stages here. Okay, that's asked in the problem. How many theoretical plates needed? Okay, so let's eliminate the intercept because we don't need this one. Mark this as negligible. I will erase. Remember this, guys, that the y-intercept purpose only is to create the feed line. So after counting the trays of the distillation units will never be needed. So cancel that one, and what will left is this one. Okay, the long at the bottom. Okay, and then we create na mga trays na siya. Okay, so ang step how to do that is to horizontal, vertical, horizontal, vertical, horizontal, vertical. You can create a lot of triangles, so that would represent your number of trays. Okay, so it's in here. So, you should connect that to the curve, equilibrium curve, or equilibrium line. Okay? Something like that. Oh my goodness. Okay, something like that. So, oh my gosh. 1. So many. Kakaloka. Okay. Okay. 2. Okay, here. 3. 1, 2, 3. 1, 2, 3. And then here also. Okay, here. Kakaloka. 4. Okay. Like that. Then if you try to connect that one here, okay, something like that, okay. Then we have here, after that here, okay, here. I-connect mo siya here, okay, like that. Guys, ayaw niyo, don't connect the XW to the curve line lang ha, because your number of stages will be cut off. Because you cannot move now in going to determine the number of stages. Mapansya pa, mamati sa chest pa. Okay, I need i-connect ito sa equilibrium line. Plus, ano yung makikita pag-connect sa equilibrium line. At ito yung i-connect sa feed line. Sa katong na-intersect sa tulo. OL, BOL, sa feed line ha. Okay? Don't do in the, or else you cannot create na the stages. Okay? Something like that, and we have here also like this. Oh, nakakaloka. Okay, 5. Okay, ang dami. 5. Okay, 6. Okay, 7. My goodness. 7, 8. Oh, 8, and then here, 9 stages. Okay, here. I will mark clearly so you can understand that. So, 1, here, kaloka, 2, 3, 4, 5, 6, 7, 8, 9. 9 theoretical plates, guys, needed for this problem. 9 theoretical stages. Okay, we don't have to subtract this by 1 or by 2 because we don't have partial condenser and we don't have also partial reboiler. So if the problem will state there's a partial condenser and partial reboiler, that's why it's called partial because it's not full. Then you have to subtract with -1 if there's a partial condenser. If there's a partial condenser and partial reboiler also 1. So if there is both partial reboiler and partial condenser, -2. Okay? Now in here, there's no point something chuba-chucho because it's very clear here that, wait ha, okay, it's very clear here that it will connect directly now, like this, oh, see? Like this. Okay, it will connect directly to the point 1. Sorry, 8 lang pala siya. 8 trees lang, kaya the others are the first equilibrium line man siya sa plotting. Sorry. So the XW is 0.1 lang naman siya. So dili lang siya tutog. Okay, hindi ko namin siya ganon. So 8 ra siya guys ha. Okay, 8 ra siya. Get the point? 8 ra siya kaya. Base man siya sa XW. It will not be based on the first plotting na equal to 0.05 here. 0.13. We have the first plot between the X and Y, the vapor and the liquid. This is not the last portion. We will base only to the last, which is XW. Okay? So that's why I commit mistakes because I do that there. Actually, you will never improve that one. Because if you try to draw a triangle also, it's still a perfect triangle. After this, 0.13. But based on my knowledge, I corrected it immediately in my brain cells. Okay, that's 0.10. Only, up to there only. It will not go beyond XW. But if you try to put that here, it's very perfect shot. And then it will stop also. Okay, because the feed line will intersect there in the value of 0.10, which is logic and realistic. And we don't have to put it in our mind. It's already intersected there. Okay, so this 8 lang siya guys ha. 8 theoretical plates. Sorry for that. Okay, muna siyang itawag na itong capital N, which is the theoretical plates. Okay, 8. Ngano ganito na 8 siya? Because there's no point something sa XW because perfect siya na triangle ra gyud siya. If there's an overlap, so you will use the ratio and proportion because it will create also a small triangle there. And that's point something. Because in distillation, there's situation like that. How many trays you will need like that? And you will account the point. For example, it needs 7.3. It needs 8.6, and it matters in your, in your answer. It will never be rounded off like this. It depends on the situation. If your instructor will really say you will round off. But in examination, go to the perfect answer you solve. For example, you solve 7.4. Okay, that is your answer, 7.4. You will never round off that one to 7.5 or 8 or to 7 only. Okay, like that. As is 7.4 of it siya. But now you can feel in the choices, but there's no 7.4 and there's 7 there, and the other choices are very far, then choose 7. If there's no 7 also, it goes directly to 8, then you round off niya, so go to 8. Something like that. The most closer in your answer. Okay, it's gonna be like that always. Nearest to your answer you solve, choose that one. Or else it's very far, then none of the above. Okay, like that. Get the point? Because it could not be denied. I answered also none of the above in the board examination. Okay, it's not all the time, it's there in the choices also. Okay, something like that. So, 8 stages and trace capital N. Guys, but if the question here will add also, what is the efficiency of your distillation unit? How can you do that? You can do that only if given the actual number of plates in your problem solving. Say here, how many theoretical plates needed if the actual plates already is 5 plates or 5 strips like that? And the question A, what is the overall efficiency of the distillation unit? Because it gives the actual plates, so theoretical plates divided by the actual plates is equal to your overall efficiency of the distillation units. Just like in mechanical advantage in machineries and equipments. Okay, work output is equal to work input times 100. That will be your mechanical advantage or the efficiency of the machine or the equipment, something like that. Okay, so more ang principle behind. Okay, for this. Okay, sa mangita ka na siya efficiency mo, ginagawin ang gamiton. O heat efficiency din sa thermodynamics, kang Clapeyron, o Sadi Carnot cycle. Second law of thermodynamics, I think so. Okay, so heat absorbed, ganun siya, minus heat release over heat absorbed times 100 also. If we are asking for the efficiency of the machine or the equipment or heating equipment, okay, usually that is a heat engine. Okay, heat engine specifically. Okay, what is the efficiency of a heat engine? So not necessarily you will find the work output or work input because the temperature only would mean a lot. Okay, you will also temperature outlet minus temperature inlet over temperature output times 100. Mo na yung overall efficiency sa heat engine. Not necessarily mo po dyan pangitao ng work. Okay, or in another way around, if there's a heat absorbed minus heat released over heat absorbed, that will be your overall efficiency of your heat engine in second law of thermodynamics. You get the point? Okay, something like that. It's just the same here. So theoretical plates over the actual plates times 100. This will be your overall efficiency of your distillation unit. Okay, but in here, we don't give the actual number of plates. Okay, but sometimes it will be given, this is the problem. Okay, you have to be extra careful for the terminologies again. Okay, so it's in here, guys. We can prove that if we increase the reflux value, we will reduce our theoretical plates. Inversely proportional. Okay? There's a reflux value of 2.5 here. If you keep on increasing this reflux value, then we need less number of theoretical plates. Okay, or theoretical trays. Because theoretical plates and theoretical trays are, dependent with each other. The actual plates and the theoretical plates if you solve in algebra. Okay? We have the formula, diba? Overall efficiency of distillation unit is equal to theoretical plates over actual plates. We solve for the actual plates. It will become theoretical plates over the overall efficiency. Now, what is the relationship if it is across in the numerator and this side? So it's directly proportional. So, theoretical plates are dependent on the actual plates. Kung imo siyang increase sa day ang kuan, actual plates. Unless if it is a minimum reflux ratio. Because as what I've read in my research, if we have the minimum reflux ratio, we are referring here for the maximum reflux ratio. Minimum reflux ratio, we will obtain an infinite number of trays. Okay? In which our formula will also change. RO is equals to LO over DO. That is for the minimum reflux ratio. But we are not considering the minimum reflux ratio. It's not mentioned. So this is regular reflux ratio or the maximum reflux ratio. So what I'm trying to emphasize that if we want to require infinite number of trays and stages, then minimum reflux is stated in the problem. Get the point? Okay. Or the minimum distillate and the minimum condensate will be given so that you can attain the minimum reflux. Okay, it's going to be like, and then if you have the minimum reflux, then substitute that also in the overall efficiency distillation unit formula, which is theoretical place over actual is a bingo. You can produce infinite number of plates raised to the power 2 by 2. Okay, but that's not the usual case because that is too impractical to have infinite number of actual plates. That's impractical really because it is costly to keep on adding stage and in your distillation unit. Really. So the more you have trays and stages, the more your distillation unit is expensive. So nobody wants that, right? If we can have a very high efficiency of our distillation unit at a very low number of trays, then go for it. Okay, because efficient na siya eh. And then trays are not really that large for so many. Then you can save cost. Okay, meaning to say we are focusing on the cost-effective relationship. It's gonna be like that cost-effective between the environment, the safety, and the quality of that unit it could produce. For the Asia, okay, quality, okay, safety, and then the cost and to the environment. Meaning to say, if that is to the environment, people are included to that. The human beings, how it could affect the people when it releases the hazards to the environment. Okay? So that's why for the impact of installation of equipment or work equipment. Could it be a modified or revised equipment or could it be a new equipment? You need to consider first the environment, which involves the people, the safety, okay, the quality. Okay, like that. Okay? And this efficiency is the one we are trying to look for, right? So actually 5 pala talaga siya. Again, environment, safety, quality, and then the efficiency. Okay? Problem also because the more we need a higher efficiency, the more we have a costly equipment. Really. Okay? It's dependent with each other. Okay? That's why that's the rule of the purchasing department to obtain the specifications before buying those materials and equipments. Okay? Because we need also to account how cost-effective are those materials, resources, and equipments really are. Okay? Like that is basing on the criteria that we are trying to look for. Since they are concerned with the financial aspect, we have to look for priority for the cost. Second na lang yung safety, third na lang yung quality, like that. But it doesn't hold true for all companies all over the world, especially Saudi Aramco. Saudi Aramco is more on safety. Okay, and environment. So, ang cost is ano na lang siya, pangatlo. Okay, environment, safety, their number 1 priority. Number 2 will be the quality. How quality is that? Because after how many years, it will not have maintenance. And you can save the operating cost in that. You get the point? And we can recover easily the initial investment or the capital cost in buying that. So, if you think intelligently, if the operating costs will be more than in your initial cost because you are trying to avoiding that because that's too high, then problem because it will undergo so much repair in the future. If you add that cost, it will be triple, quadruple for your initial cost and capital cost. So engineers will think like that. Okay? You get the point? It's not really for one-time thinking. It's also you are looking for the sustainability for your equipment that it could last for a long period of time. Such like this, the distribution column should be designed properly, okay, according to its parameter, environment, safety, quality, efficiency. Ganon. Okay? So, the sustainability will be basing on the quality, right? If you are having a very quality product, then it will sustain for how many period of years? Correct? Okay, that's why others prefer to have a quality product. Because if you keep on buying and then you buy again after 3 months, it will double, triple your expenses or capital or your initial investment. You got a point? Okay, that's just like having a jowa. You need to have a quality jowa. Because if you don't have a quality girlfriends, okay, and boyfriends, and then after 3 months you will change another. Because you are not compatible with each other. You don't have the same characteristic, attitude, and then you keep on quarreling with each other to some small issues, something like that, and you don't have understanding, and then that means you are not compatible with each other and you will separate them. Okay? Just like that also the principle. You have to choose according to the set of standards and parameters. Okay? Thank you so much for watching this live streaming second segment of problem solving of distillation by using McCabe field method. Guys, wala na lang ko ni-complete sa kanil ko ano asa to? Kani siya wag man yun siya W is equals to F minus D, F is equals to D plus W, D is equals to F minus W. Wag man yun gihatag sa problem. Okay, so if we treat this as a problem in board examination or future examination, just put none of the above. Okay, because it's impossible, guys. See, we have here so many more fractions. Then it needs 5 equations to calculate for the W, F, and at least there must be value of V, there must be a value of D. So this is only a tricky question. The disadvantage of a tricky question is it will consume you a lot of time, something like that, and leave it, okay? Because it will consume you a lot of time. There's still a lot of questions somewhere out there, then easy and average, then it will lose your points, okay? And you cannot focus now very well in the most easy and average because you are focusing on a difficult question in which you want really to dig out. So escape that one and then come back again, okay? Like that. You get the point? So things like this, it will, steer your mind. Okay, what is the, how much feed to be introduced? Okay, how much distillate produced? How much bottom product goes away? In fact, there's no amount of feed going to the distillation unit. Diba? Common sense? And more fractions will not help because there's no also value of the distillate that I can say. Then why should I force myself? There are 5 equations. There are 5 required, and then there's also need for 5 equations and formulas. And we know that we don't have 5 formulas for this. Okay? You got the point? And then in y-intercept formulas also, in the slope formulas also, in the rectifying line, and in the feed line, there's no involvement also with the feed. Distillate and condensate is always small fractions expressed there, and the reflux, right? So it adds with 8. So leave it and just put your answer none of the above if it is a multiple choice. Or if it is a problem solving, leave your answer as is, like this. And you explain to your teacher, sir, we don't have the distillate, we don't have the condensate, we don't have the feed, we cannot solve the quantity, sir. And measure him also if he answers you very well. Because it's gonna be like that. It's not only the instructors that will, that will measure your learning. You should also measure the learning of your instructors. The reverse, the complementary situation. It's not always the student that he tries or she tries to measure the mental capacity. Ask also to him his mental capacity. Okay? In reverse, let's see. And he will explain you, oh, we can solve this, and better, because he can solve pala. At least I know. Okay, I'm a student. Yes, sir. How can we solve that one? Okay, like that. And then you ask question, because why questions are the most intelligent questions. Why? WHY. If you don't understand, you have to ask. Okay, that's the rule of thumb, or the very, very good, effective strategy of a student. Okay, especially if you are sitting in front of the white or the blackboard or the whiteboard. If you cannot understand, raise your hand. Sir, why like this? Why like this? Okay, you have to be conversant. Okay, you need to talk. Okay, you need to ask questions so that you can understand. And it could help also others to understand. Sure, some also don't understand, but they just don't voice out. Okay? They just don't voice out, but they are also don't understand. Not all can understand very well, because not all having a very super intelligent mental capacity. Okay, it should be average only. If there are 50, most of the 20 can understand, but the other also have cannot understand. Okay, something like, or if it is very easy, all can understand. But even if it is very easy, still, there's few cannot understand. Because it depends on the mental ability. That's why if you are instructors, we'll level our discussion to the majority of the students so that they will understand very well. So what we're going to do is to let our discussion to be systematized, organized, and give them a set of possible similarities for the quantities, not only going to the same terminology always over and over again, and presenting sample problems is just the same in the book, and then you give questions not related to the discussion. Something like that. Okay, you should do balance, 50-50. Difficult, one average, and one easy. Okay, so that at least 2 over 1, the students will pass. Okay, because they cannot answer. We should assume that the one difficult they cannot answer. Only 2, so 2 over 3, so at least 70% is okay, right? Okay, something like that. Do not put all difficult. Of course, nobody will pass on your subject. And then during the rank, what do you call this one? Appraisal. So it will reflect to you. You are not a good instructor if all your students will fail. Or meaning they did not understand the way how you discuss. Okay? So to make it safe, do it 50-50 or above 50 in giving examinations. I'm not a legit instructor or professor or teacher, but I just read some books, some references, and I keep on reading also strategies in, prof ed, professional education and teaching. Okay? Okay, so that's my hobby. Okay, reading and researching for Sotero or something like that. Okay, even though I'm not a teacher, a certified instructor to a certain university. This is just only vlogging and sharing information to any one of you guys. Okay, thank you so much. If you think you like this video, you can comment down below in the comment section. If you are not subscribing yet my YT channel, then you can subscribe and you can click the notification bell for some news updates about everything here. Eternal voice, could it be occupational safety and health, pure sciences, a little bit of mathematics, personal vlogging, specifically singing, biritan, and also personal vloggings also. Not only biritan, pwede sa mga slow lang siya. Okay, and then unboxing or whatever that comes to my mind. Multiple topics to be my contents in my YT channel. Okay, but don't expect me to have creativity and the animation, the special effects, because I'm not good in computer. Okay, this is just only conventional way of vlogging and streaming. Only purely talking and the paper, pen, like that, collapse. See, I don't have any visual aids here to add colors and attractions to your eyes. Okay, it's only the pencil pen, the sheet of paper, the calculator, and the ruler. Okay, how simple are this and how basic are this my visual aids. Okay, in fact, I don't have also my whiteboard. I did not yet install that because I found difficulty to find the stand for my phone. Very difficult to find that one. I can't find that one. Okay, for now I cannot do the live streaming with having my camera set up in the stand, mobile phone stand, and then I will discuss in the whiteboard, magnetic whiteboard, but I don't have to do that because it's still not yet installed. Maybe in the future, but still I cannot get it. Okay, how can I do this? How can I bring this to my country of origin? This is very huge. Okay, I want this to bring in my home. Okay, like it's really big, right? It's allowed in the airplane to bring this magnetic whiteboard with a wide dimension. Okay, I don't think so. Oh, never mind. Okay, so that's it. God bless everybody. Thank you so much. Okay, I don't have to see you later now. I don't have to say that because my vlogging and live streamings have officially ended. Bayang magiliw, perlas ng silanganan, alab ang puso, sa dibdib mo'y buhay. Lupang hinirang, duyan ka ng magiting, sa manlulupi, di ka pasisiin. Sa dagat at bundok, sa simoy at sa langit mong bugaw, may dilat ang tula at awit sa paglayang minamahal. Ang kisap ng watawat mo'y tagumpay na nagniningning, ang bituin at araw ng kalapat may di magdidilim. Lupa ng araw ng luwa natin pagsinta na nasana aming ligaya ng pagmalagapi ang matay ng dahil sa iyo. Sorry, I forgot the lyrics. Okay? I am a singer at your voice, officially signed.